Hello and welcome back to Math 20-2. Today we're doing your first lesson on quadratic equations, which is just a review of factoring. Now if you remember from grade 10, we did the box method. It's a nice simple way of helping us factor. So I'm just going to review the box method right here and what the box method is for those who might not have had me. So if we have 12 and 8, we want two numbers that multiply to give 12 and add to give us 8 to fit in here. So let's break down 8 into its factors. That is the same as 4 multiplied by 3. Well, if I add 4 and 3 together, that doesn't give me 7. So let's try 2 and 2. Now, I can multiply 2 and 3. That gives me 6. And then I'm left with a 2. So 6 and 2. That works. 6 plus 2 is 8. Okay? Let's try the next one here. We have 36 and 15. Once again, this is positive, and that's positive, so both must be positive numbers. So what's 36? We could break that down as 6 multiplied by 6. But 6 plus 6, does that give us 15? No, it doesn't. So we're going to have to break down at least one of these more. Let's try 3 and 2. Well, 3 times 6 is 18 plus 2 is 20. That doesn't give us 15. Let's try this one. 6 times 2 is 12 plus 3, 15. So that works. So these together and that. So we have 3 and 12. Now I take a look at this next one here. We have a little bit of a pickle coming up. This is positive, that's negative. So that means we must have, if this is negative, we have at least one negative, right? Here this is positive. Well, the only way we could get a positive is if we multiply two negatives together, two positives. If this is negative, we have at least one negative, so that means it's going to be a negative and a negative. Break this down, I have 7 and 8. 7 plus 8 is 15. So we have negative 8 and negative 7. Okay? Let's take a look at this next one here. Negative 40. And this is positive. And that's negative. So that means one of them being multiplied together must be a negative. And we know from this that the bigger one is a positive. Okay? So I'm going to break this down. We have 10 and 4. Now the difference of this is 6. This is going to mean there should be a difference. If I added a positive 10 to a negative 4, that gives me 6. Well, that's not going to work, so we have to break one of these down a bit more. Let's try this. 5 and 2. Well, 5 times 4 is 20. 20 minus 2 is going to give me not what I want, I don't think. 20 minus 2 is 18. No. Let's try this. 2 times 4 is 8. Take away 5 is 3. Ah, that works. So 8 and 5. Oh, sorry. 8 and negative 5. That will do it, which gives me 3. And next one is 21. Well, that's 7 and 3. I know the factors of those. But here we go. This is negative, and so is that. So one is negative, one is positive. Which one's bigger? The negative. So 7 and 3. That and that gives me negative 4. Add these together, gives me that. Multiply them together, gives me that. Add these together, gives me that. Multiply them together, gives me that. So that's our whole idea behind this, is the box method. So here we go. Let's take a look now at our first class example, after that little bit of a review. So we have x squared plus 13x plus 30. So let's do a little box there again. So we have 30 and 13. Now we want two numbers that multiply together to give us 30. This one always goes on the outside, and this one goes on the bottom. So multiply together to give us our constant, and to give us the coefficient of the x to the power 1, we add. We want the sum. So 30, we could have 10 and 3. Well, 10 plus 3 is 13, so it's 10 and 3. So we have to fix that up. We have x plus 10, and we have x minus 3. Oh, sorry, plus 3. Let's take a look at our next one. We have negative 13 and 30. So make my box. We have negative 30 and negative 13. Once again, outside what we're multiplying to get and what we're adding. Now I look at this. This is negative and that's negative. Both are negative. So one must be negative and one must be positive. My bigger one should be the negative. Okay? So, we have 6 and 5. Well, that's not going to work. 2, and 3. Well, let's try this. 2 times 5 is 10, minus 3 is 7. Nope. 3 times 5 is 15, minus 2. That works. So the negative 15 on top and the 2 there. So once again, I'm going to get x minus 15 and then x plus 2. Let's take a look at my next one here. Make it a bit bigger. We have negative 11 and 30. Okay, so this tells me both must be negative because this is positive and this is telling me there's at least one negative and this is positive, so that means both of them are the same, so both must be negative. So we have a negative and a negative. I break this down, we could have 10 and 3. Nope, I add those together, it gives me 13, 6, or 2 and 5. Well, 2 times 3 is 6, plus 5 is 11. So we have 6 and 5. So we have x minus 5 and x minus 6. And that's how we factor. Okay? So hopefully you understood that, and that's our first little bit of review. Now the next part is, when we have no b, how do we do that? That's like doing these box methods. And I have, let's see, an example of this would be, and I'll have 64, and normally it has to be a negative. It only works if there's a negative and a 0. Well, these must be the same, added must be a difference of the same, so that would be 8 and 8. So plus 8 minus 8. And every time, if this is 0 and we're subtracting something, these two have to be the same. So that's called a difference of squares. Here's some examples. If I take a look at this, this here is a difference of squares. I could square this and I could square this, and it's a difference. So to factor this, I'm going to get x minus, because the square root of x squared is x, and the square root of 49 is 7, minus 7. And then I have to do x plus 7. So I have to do it once subtracting and once minus. Because it's kind of like what we said there. This here would be the same as x squared minus 64. They have to be the same. One has to be added, one has to be subtracted. So here we go. Let's try this t squared minus 64. Well, I kind of already did that one in my example. That's, whoops, t minus 8. And then we have t plus 8. Okay? Let's try the next one. 25x squared subtract 1. Now this could be a pickle. But I could square root this, and I could square root that, can't I? If I square root 25x squared, that's 5x. And what's square root of 1 is 1. It's 1. So that's 5x plus 1. We have to subtract and minus. Let's take a look at the next one. Look, I can square root this, and I can square root that. So that's going to give me 10x minus 9. The square root of that is 9. Square root of that is 10x. And we have 10x plus 9. And that's it. Okay? Now, here is our next one. It says, write the following functions in factored form. So here, we have a little bit of problem. It looks like it should be a difference of squares, but this isn't a perfect square root, neither is this. So first, I'm going to factor out the 5. And we're left with x squared minus 4. Now looking at this here is a perfect difference of squares. Both of them are perfect squares. So I get 5, I get x minus 2, and x plus 2. Because I could square root both the x squared and the 4 nicely. Okay, they're perfect squares, so that's a perfect difference of squares. Let's take a look at the next one here. Ooh, we have this number in front of me. I don't like that number in front of that coefficient. And we have 3 terms. So I'm going to take that out. So I'm going to get 2x squared. Now, if I take the 2 out of this, I must take it out of everything, remember. 2x squared, and we get plus 8x plus 15. That looks good, because if I was to put this back in, I have to multiply everything by that too. Now, I look at this, I'm going to do my box method. I have 15, and I have 8. Okay, so, let's take a look at this. We have 3 and 5. Both must be positive, because they're both positive, so that's going to be 3 and 5. Oh, so that's equal to 2, x plus 3, and x plus 5. That's it. Next one here, 16 and 64. Well, can I square root both of these? Are both of these perfect squares, 16 and 64? Yes, they are. So this one's actually pretty easy. I'm just going to go right now, and I go square, and I'm square root both. So I have 4x minus minus 8, and I have 4x plus 8. When I look at this, I think I could take out 4 from both of these. This here, I could take out, divide both of those by 4. So that's the same as 4x minus 2, and then we could take out another 4 here. Oops, sorry. 4, and we could have x plus 2, which gives me the same as 16x minus 2, and then we have x plus 2. An easier way might have been to divide both of these by 16 first. So I could have had 16x squared minus 4. And then I could break this, square root both, and that would give me the same as this in my next step. So there's two ways you could have done that one. Okay, it's up to you which one you find easier. Here's the next one. I look at this. Normally the best idea is, can we divide everything by the coefficient? Yes. So I'm going to take out -3, and I'm left with x squared. Now if I divide this by -3, that gives me -2x, and then I divide that by -3, that's going to give me -3. So now I could do by box method. I have -2, -2 and -3. This is just 3 and 1. They're both negative. That means one must be negative, one must be positive. The bigger one is going to have to be negative because it's negative on the bottom. So we have 3 and 1. So that is -3, x minus 3, and x plus 1. And that's how we do that. Okay? Now, our last sets of examples here, hopefully we can get through this fast. This is factor the following by removing the greatest common factor. Alright, so we want to remove the greatest common factor from everything. So I look at both of this here. I could remove from this an x subtract 9, and from this one here I could remove an x subtract 9. So what I'm left with, x subtract 9, and what are we left inside? 3x minus 2. Okay, let's take a look at this one. We could subtract, there's 2x plus 1 in both. So we're left with 2x plus 1 multiplied by 5x plus 7. Same idea here. There's a 2x plus 1 and a 2x plus 1. But remember, there's an imaginary 1 there. So I'm going to have 2x plus 1. If I divide both of these by 2x plus 1, I'm going to be left with 9x. And then here is 2x plus 1 divided by 2x plus 1 is 1. 9x plus 1. Okay? Because that's a plus sign. Now let's take a look at this next one. We're going to, it's 3 minus 2x and 3 minus 2x. So 3 subtract 2x. And here we're left with 8 plus x. And that's it. Hopefully you get that. Okay? Last one. It says for this one, factor the following polynomials by grouping. So we want to group this. Alright. So by grouping. So I'm just going to start putting in my brackets here, like this. From these here, I could take out an x. So I'm left with x plus 4. And then here, I could take out plus. And here, I could take out a 6. Plus 6, and then we are left with x plus 4. So it's now we're left with the same thing as we had on top here, something like that we had on top there, those questions. So we're left with x plus 4 and x plus 6. Okay? To tell you the truth, when I do this, normally I combine them and then I just do my box method. But I'm just going to show you how to do these ones here. So let's take a look at this one. My brackets are on these. So right here I could take out a 2x from both of these. So we have 2x. And we're going to be left with x minus 4. And we have to plus, because it's a plus sign. What can we take out of both of these? A 3. And that's going to be x minus 12. Well, is there anything I could take out? Oh, x minus 4. Sorry, x minus 4 again. So is there anything I could take out? I could take out an x minus 4. Okay, because both of these have an x minus 4. So let's take a look at this one here. Same idea. Put my brackets on. Put my brackets on. I could take out here 4a. So I'm going to have 4a. Now I'm left with 2a minus 1. Here, I can't take out anything, plus 2a minus 1. Okay? Now I look at that, that's kind of similar to this question here. I have 2a minus 1, 2a minus 1. I could divide both of those by. So I have 2a minus 1. And I'm left with 4a. That all has to be multiplied with 4a. And also, if I divide by 2a minus 1, there's also a plus 1 there. So that's it. Okay? Now here's this one here. One more we're going to do. See if you guys can get it. Put in my brackets. What can I divide both of these by? 3x. I'm going to be left with 2x minus 3. What can I divide both of these by? 2. I'm left with 2x plus 3. So I could divide that by 2. So it's subtracting. Now, here's a little interesting thing there. Maybe, but this is still, I'm going to add, and there's still a negative there, right? Because this one was negative. So maybe I should take out a negative 2x. So if I take out a negative 2, this would be negative as well. So it's going to be 3x, 2x minus 3. Because here, if I take out negative 2x, this thing changes both signs. So we want that coefficient to be positive. So it's going to be minus 2. And here we're going to have 2x minus 3. Divide both of them by negative 2, and that works better. And this will cancel off with this. We can divide both by that, so I get 2x minus 3. And I get 3x subtract 2. Okay? And that's it. Let's take a look at this one for my second last one. Or my last question. So here and here. What can we do? Oh, I'm going to put my bracket there, so we keep that 2x in there. So we have 6, both of these divided by 8x. And we're going to be left with 2x subtract 1. Now the next one here, we want to take out that negative 2. So negative 2. Now if I take out the negative 2, this is divided by negative 2 as well. Oh, actually no, we don't want to, because that can't be divided by negative 2. So we're just going to leave it like that. And we have minus bracket 2x, so I'm just going to put the bracket there, and subtract 1. Why? Because I divided everything here by negative 1 and negative 1. Okay? So if I put the brackets here, that negative is multiplied into both. So now, we look at this, we have 2x subtract 1, and we have 8x minus 1. And that's how we do those. So hopefully you understand. If you have any questions, ask me tomorrow as we'll work on these together.